Let's dive into a classic implementation of 8x8 multiplication on the Intel 8080. This routine uses the AI register and register E for factors and HL for the result. On entry, factors are loaded into the accumulator and register E. Now, we prepare the internal workspace. We clear register D to make DE a 16-bit multiplican, reset our HL result pair to 0, and set our loop counter to 8. Inside the loop, the first step is rotate right. We rotate the accumulator right through carry to extract the next bit of our multiplier. Then, jump no carry test. If the carry is 0, we skip the addition and jump straight to the shifting phase. But if the bit is 1, we execute DAD-D. We add our 16-bit multiplican directly into the HL product pair. Now for the shift. Since we can't shift DE directly, we use a clever swap sequence: exchange, double add HL, and exchange again. First, exchange swaps the product in HL with the multiplican in DE. This brings the multiplican into the primary math register. Next, DAD-H adds HL to itself. This effectively shifts our 16-bit multiplic and left by 1 bit, preparing it for the next power of 2. Finally, another exchange puts everything back where it belongs. We're ready for the next iteration. We decrement our counter in register B. If it hasn't reached 0, we jump back to the top and process the next bit. After 8 cycles, the routine hits return. The full 16-bit product is now waiting for you in the HL register pair. This implementation is precise and efficient, leveraging the 16-bit instructions to handle the heavy lifting. From custom routines to modern compilers, these building blocks are eternal. Happy coding!